I'm Jonathan. This is Anahita. So as Jose said, we've both been a student at DSR for the past 3 months now. And I'm going to present you our project, Become an Expert in Any Field. So we believe that to become an expert in a field like medicine, data science, physics, all that, you need to be able to read and understand research papers. The thing is that research papers are very dense and very dense in information and full of technical keywords that maybe as a beginner or student it's hard to fully grasp. So we built a tool to solve that problem. So first I will demo to you what we build our tool to take a paper, explain every keyword in it, and then Anahita will come and show you how once you read multiple papers, you can see how they're all connected together and what's the link between them. And then we'll go a bit further what we could improve. It was a 2 weeks, 3 weeks project, so there's a lot of room for improvement. All right, so demo time. Okay, so this is a website we built using Streamlit, and in the background it calls OpenAI API to get answer from ChatGPT. So I'm going to upload the paper, Attention is All You Need. So for the one that I know, it's a paper that introduces the transformer architecture, which is what ChatGPT is made of. Here's a little overview of the paper, what it looks like. And here we have the first explanation of it. And I won't go through the entire thing, but just to show you how our tool works, it's basically that you provide a quick explanation, and then on some technical keyword, like here, recurrent neural network, RNN, you can see that the word is underlined. And if you hover over it, you will get an explanation of that keyword. And then you can click on it. Yeah, so here you can see a bit more what I wanted to show, that hovering over a keyword like a transformer I show, and then clicking on it, you will get the full explanation of that keyword here. And then that explanation has keywords shown in it that can also be explained. So even if you don't know something about the topic, you can go deeper and deeper until you reach that part that is very simple, but maybe you don't know it, and you go all the way through it. So when we upload a PDF on it, we take the text out of it, we send it to ChatGPT, ChatGPT explain it, it gives us all that full explanation that you see here. Then we ask him to extract keywords like RNN, LSTM, here encoder, decoder architecture. We get that list of things, and then we ask him to explain the keywords. And the explanation of keywords is done in parallel because it's much faster. We can explain all, instead of waiting for each keyword after one another, we can explain it all at the same time, much faster. And then through the website and the HTML, we re-inject it to have this whole interface. We can click on it and go deeper through it.
But to explain a bit of how we are building these kind of graphs that we have here, is like the main concept on back of that is that we get the one paper as a PDF file, and then we break it down to its sections. So like one PDF will be converted to different nodes, and each nodes are representing the section in this paper. And then after that, we try to find the connectivity of these sections in the paper. And this connectivity is trying to tell to us how similar these are together, these nodes. And to find this similarity, we are also using the ChatGPT LLM. And what we do is that actually we input the text as the whole section, we pass it through the embedding layers of the model layer, and then we get the vector representation for the text. And this is like what is happening in reality is that is kind of dense feature extraction, that it would help us to find the similarity between that. So what happened after that, we have like a vector representing the whole text, and then we can use the cosine similarity to find how relevant these two different sections are together. So for example, here what we see is that, for example, kind of having in a 2D representation a vector for the apple and orange, and we could say when two vectors are more aligned to each other, they are more similar, and when they are having more angle in between, that means they are further away and less similar. And the cosine similarity, it will find the projection of this vector on top of each other, and that is why when they are more aligned, they are more similar. So what we did is that, okay, we get the whole PDF, we did the section extraction, did the embedding for each section, find the similarity, and based on that, we build the metrics of connectivity for the graph. And as you see here is like we have one PDF and we have one graph for that. But the thing is that other than having the nodes and edges there, we also have different size in the nodes. And what we are using for that, it's a page rank method. And what means here actually to say is that when you have a bigger node, it means that this node is more important to read. So what we wanted to have is that, for example, you are a new researcher, or you have never read a paper, or even you have been reading paper for a long time. But what's important is to know where of the paper I can get the most dense information. And this could actually differ, like we say that maybe for everyone thinking, yeah, it's obvious to read the abstract first, but I could show you for different papers, this is different. And actually it shows, it could also help researchers to improve their writings. For example, you can get the feedback that, okay, when the abstract is not related to the whole paper, it could guide you that you can add more information in your writing. And what this, how this works in reality is based on the PageRank method that was used first by Google, I think. And that is, the concept is that items that are more referenced are more relevant. And in the example, what you see to the left is that you see that this circle is a marker. So this is not a node of the graph, the blue one. But the green ones, they are the nodes that are referenced less. So that is why they have the smaller radius. And then the item that is referenced with all other items has the biggest radius. And also what it do in that is that when an item is referenced with a big giant reference, that one also get the higher rank in this computation. And it's a iterative method that is actually working based on the flow. And that is why also it's kind of giving a new structure compared to this flat structure that we have in the paper to follow and read. So yeah, here you can see it's below the paper. That was the first paper you saw. And when you click on the nodes, you can see the text that is extracted for that. And also you have a link to the full paper. And then it's the part that Jonathan presented for the keyword extraction. And so here you can see the keywords. You have already seen it. Yeah, and then it's possible to compare. So for example, imagine you have different papers. You can also load that as another reference to that. So, and different colors are referring to different papers. So here you see two different papers that they have no relations. And below the third paper here, and actually there is, probably you don't see well, but there are these edges between them. And one of the possibilities, click on the edge, and then it will use the ChatGPT, load these two sections, and then find what is the similarity between them and also what are the differences. So the nodes in comments are the similarity of these two parts of the papers, and then the outer nodes are the differences. And it's also like, usually, I mean, in one research paper, there is a last section for all the references. And one additional thing we have added into that you select a paper. For example, here we are using the attention paper for it, and then it will extract all the references, load them from the, download them, and then embed them, and then generate the graph. And this is like the threshold that you can change to define how you want to find the similarity between them. And here you see the attention paper. And then what is quite interesting is that usually as a researcher, it's hard to know what should be next to read. And here we can use the PageRank as a recommender that, okay, among all of these references, one of the most reliable and important reference is this node with this big radius. And also we can provide the link to the paper that you can go and read it. To summarize, we have had two main use cases. One is that you have read a lot of paper, you can load them and visualize them and relate to them to review your work. And for example, you have your Mendeley, you can upload all of your PDF files and get a graph and relation out of that. Another scenario is that you want to find the related work of a paper and find and plan for the next study that you want to do. And to compare our work to other existing work, one is these connected papers, and the other one is two different platforms that they are extracting the key concepts, and to say we are standing somewhere in between in our graph representation, because in one of them, they're extracting the whole paper and do embedding, and the other one, they're extracting keywords, but we are doing embedding for each section of paper. So we get a bit of the structure of the paper into extracting the context and make it a bit more less dense graph compared to this one, but a bit more information compared to connected papers. And as a future work to say, it's like improving the UI, like a bit more stable platform, definitely. You experienced it today, but also it's on the back end and front end. The Streamlit is not the easy one to have a lot of features. And it's also one of the concepts we wanted to have is that when you experience the keywords in these text definitions, it's holding this, we are storing this data in our database, but we didn't have the time to show it as a graph representation that is showing the personal knowledge that you have gained and you can review what you have learned. And also we were thinking it would be good to have a study path recommendation. So now we see it in a PageRank, but actually to have it as a app integrated that it recommends to you, this will be a next thing to look in or next things to study. And also what we thought it would be interesting is to have a feature that it gives scientific writing feedback. So you have written a paper and you want to see how good the flow of your paper it is, and you can input it and compare it to one of a good paper that have a lot of reviews and compare how you can improve your writing on that. And also on the PDF extraction, it takes a lot of work, even though there are now language models that helps to extractions, but it doesn't work as stable. And now we are just working on archive paper. So it could be good that we could also use the images relate to the texts and also extract the tables out of that.
Also some other area about the keyword explanation. So about that part, what I wanted to do at first was to have like the keyword explanation directly in the PDF. I thought it would be quite nice. Then the problem was Streamlit to make it really hard to work with PDF. So we had to choose that kind of just having an explanation from ChatGPT and then explaining the keywords in there. Also, keyword explanation can be better. We could add some extra information from Google search, then feed it to ChatGPT. Even other paper, currently we just selected from the current paper. That's all the context that ChatGPT has. And then on top of that, yeah, we could have books, other active paper that you could use in it. This is not currently the case.